All right, so when it comes to things called natural logarithms are based on this number e. And we've talked about how e is an irrational number. It's about 2.7. And let's pull up some toolbars here. So e is about 2.7, kind of like pi is about 3.141592, right? E is a number like pi. And for our purposes, you don't have to worry about the relationship with e in calculus or any of this thing. You just have to worry about its relationship with logarithms, which are inverse functions of exponents. So here we have this number e. So you got to know what e is, okay? And then here's an idea, and this is more of an idea, more of a definition. Be sure to memorize that the natural log of a is equal to log base e of a. So here we have this idea, ln, and ln means natural logarithm. And they just call it natural logarithm because this number e is popping up in nature a bit. It pops up in a lot of places, kind of like pi does. And so they call this the natural logarithm. I also want to give you this. Log base 10 is called the common logarithm. Log base 10 is called the common logarithm. Probably called the common logarithm because our number system is a base 10 system. And so the log base 10 is common to our number system. So these are two very important ideas. ln is the natural logarithm, which also is equal to log base e. So the natural logarithm is log base e. The common logarithm is log base 10. So you kind of have to know these two ideas. And maybe what we'll do is I'll get rid of the pi up here. Move this stuff up here. So that's important information to know. Natural log is log base e. Common log is log base 10. So when we take a look at this problem, natural log of e, this is ln, the letter L and the letter N, ln of e. So ln of e is the same as log base e of e. And what did we say log base e of e is? Or log base x of x? Yeah, it's 1. So this is equal to 1. So we're just going to run through a couple examples of how to use the natural logarithm. Natural log of 1, so that's going to be ln of 1, which is log base e of 1. And what is this equal to? Again, remember we talked about when, or if you wanted to, you could say y equals this, and then you could move stuff around. So you could say y to the first power equals, whoops, not y to the first power, you'd say e to what power? E to the y power equals 1. And this is going to be 0. Because y equals 0. Y equals 0. So the log base anything of 1 is equal to 0. But this is the idea that I want you to understand. If you see these letters ln, that just means log base e, which means log base 2.7, about 2.7. Okay? Let's take a look at some more examples. So with these examples, you may notice that on your calculator or on your computer, you only have 2 log functions. You have the common log, which is written, if we say common log. On your calculator, there's a button that says log. That's the common log button. That is log base 10. And you also have the natural log button, which usually is up above the log button, and that's ln. That's log base e. So these are the only two logarithm buttons on your calculator, log base 10 and log base e. These are also the only two buttons that you'll see on most computer programs. So anytime you're using technology to try to evaluate a logarithm, you have two choices for a base 10 and base e. Well, when we have a problem like log base 4 of 7, so here we go, y equals log base 4 of 7. We can't put this in our calculator. Our calculator doesn't have a log base 4 button. And so what we have to do is change this base 4 into base 10. And that's what this problem asks us to do. And how do we know to do base 10? Because it says convert it using common logarithms. So here's the change of base formula. So we have here log base b of m equals log base a of m divided by log base a of b. And so let's highlight this and make some comparisons. Here's b, here's b, here's b, and here is m, here's m, here's m. And they want us to use the common logs. So that means, in this case, we want to do log base 10. Remember, log base 10 is the common log. So to do this, we're going to say, we'll say log base 4 of 7 is equal to log base 10 of 7 divided by log base 10 of 4. And this you can plug in your calculator. You say log base 10 of 7, you push 7 and then the log button, and then you push 4 and the log button. You divide those two numbers, and this is what log base 4 of 7 is equal to. You have to run a conversion on this. Limitations of technology. But this is also handy if you want to convert from different bases. Okay, questions on this? We're also going to do a change of base, the same idea, but with the natural logs. And so this time we want to use the natural logarithms. And so instead of using log base 10, we're going to use log base e, or ln. So again, here's our change of base formula. Log base b of m is equal to log base a of m divided by log base a of b. And once again, a is going to be the natural log, b is our base, and m is what we're taking the log of. So if we use this formula, we'll say log base 4 of 7 is equal to ln of 7 divided by ln of 4. And on your calculator, you just push ln. If you want to write this a different way, you'd say log base e of 7 divided by log base e of 4. And this is how you convert from one base to another base. Basically, this number gets moved up to the numerator, and this number gets moved to the denominator. So this is change of base formulas, a way of converting from one base to another base. Okay? And so going back to this graph of E, and remember that E is about 2.7. This is what e to the x equals. And so every time you see e, you're just thinking 2.7 to the x power. And so this is a number greater than 1. So e is greater than 1. So this is a growth function, exponential growth. And you can see this is what its graph looks like. That's the graph of e to the x. If you want to graph e as a decay function, you raise it to the negative power. So think about this. E to the negative x power is 1 over e to the x, which is 1 over 2.7 to the x. And this number is a decay function. So here's decay, and here's growth. So here's using e as a growth function, and here's using e as a decay function. And these are exponential. Exponential. So we've looked at exponential functions before, and then after looking at exponential functions, we talked about logarithmic functions. So if e is the base of your exponential function, then ln, log base e, is your log function. And so here's an example of a log function. Now this log function has a shift. This log function happens to be shifted to the left, and I wish they didn't do this. If we said ln of x, let's just graph ln of x. It's going to look something like this. Like this. So this is ln of x, or log base e of x. And the one in red has a shift on it, shifting it to the right, three units. All right, so we kind of want to make the connection. E to the x is the exponential format, and ln of x is the log format. And these two are inverse functions. E to the x is the inverse of log, natural log of x, and natural log is the inverse of e to the x. And these are just special cases, a very special case of logs. Questions on this?